So over here we just created one circuit. So now we are going to little bit advanced about reading. So we have read over here one pin from the Arduino, but before that we must understand about Arduino. One second. We must understand about voltage divider rule as well as potentiometer, that how potentiometer is working and how we can use it for our applications. That is very important. If we are not familiar about potentiometer and we are not able to use it directly with the Arduino, because there are plenty of application based on this potentiometer in IoT. So how we can use it, I'm just going to discuss. Yes. So first of all, we will discuss about potentiometer, that how it is being working and how we can use it for our applications. So this one is, let me show you potentiometer first. Yes. So this one is a potentiometer, how it is working. So potentiometer is a simple resistor, variable resistor. So there is one important point that I'm just going to discuss right now. What is that point? That whenever we are going to use any kind of resistive sensor, so resistive sensor give output in the format of resistance. Mean, if we are using Ldr sensor, in Ldr sensor, whenever light intensity fall on the Ldr, then resistance of that sensor will change. But we are not able to read resistance directly in any microcontroller. So we cannot read directly resistance in microcontroller. So microcontroller will read any signal in the format of voltage. So how we can convert that resistive signal in a voltage, that is very important. If you get understood about that conversion, then 70% of sensor interface you will get familiar about that. So it's very interesting and very useful. Why it is useful? That 70% of sensors are resistive type. If we talk about FSR, force resistive sensor for force measurement, if we talk about potentiometer, if we talk about LDR, if we talk about flex sensor, all sensor are resistive type. Mean these sensor, how you will identify that these are resistive type? So in these sensor, you will find two output pin. So in two output, but in sensor interfacing, we require 3 pins. For any sensor whichsoever you are going to use, there will be minimum 3 pins. So first pin will be ground, second or third might be, they can be interchanged. So one pin will be ground and second pin will be VCC 5 volt, or third pin will be a signal pin. So maximum sensor you will find 3 pins. So how you can use this potentiometer, and how you can use any kind of resistive sensor for your applications, and how you can interface that kind of resistive sensor with Arduino. That is very important. So over here you can see in potentiometer voltage divider rule will work. So what is voltage divider rule? Voltage divider rule used to say that whenever we are going to connect any power supply and with 2 load resistor over here, then at middle of 2 resistance we will get output voltage that will be divided across these 2 resistance. So whatever output voltage we will get from over here, that is E0, will be divided by 2 resistor R1 and R2. Mean we can change output voltage according to changing this resistance. Mean we will change the resistance value and output voltage will get changed. So how it will affect on the sensor? Like if R1 and R2 we are using, so what will be the formula of voltage divider rule? That is very important to understand, and then how it is working, then you will make it clear by doing it. So let's see how it is working. So over here, I'm just going to make a circuit of voltage divider. So kindly let me give excuse because my writing is not right now too much clear because I'm not using mouse. So I'm using just touchpad in PC. So over here I have connected battery, and these are two resistance. This one is R1 and this one is R2. So these are two resistance. Hope you are understanding it. Okay. So now what we have to do, R1 and R2, this one is VS for supply voltage. When we are supplying this voltage and we are getting output from over here, that is V output. So what will be the formula for that? This one is R1 and this one is R1 and R2. These are two resistance. Don't get confused about resistance. So over here, what will be the output voltage according to resistance? What will be the formula? So this one will be the formula. V output is equal to V supply, whatever supply voltage we are giving, multiply R2. So above side there will be R2 and below side will be sum of two resistance, R1 plus R2. R1 plus R2. This one is a formula of voltage divider rule. So V output is equal to V supply into R2 divided by R1 plus R2. So just suppose R1, I'm just giving some example so that you can calculate accordingly. So I'm going to change R1 and R2 value, and then you have to tell what will be the output voltage. So over here, I'm going to make it 1 ohm and 1 ohm. What will be the output voltage? R1 is 1 and R2 is 1. What will be the output voltage? So kindly tell 50% half. Okay, we will get half voltage. When R1 and R2 are equal, then we will get output that is equal to 1 by 2 of supply voltage. 1 by 2 of supply voltage. Supply voltage is Vs. So similar way you can perform any operation with the help of this. So now what I'm going to do, if R1, tell me the output voltage when R1 is 0. When R1 value is 0, then what will be the output voltage? Kindly tell. So what will be the output voltage when R1 is 0? If R1 is 0, then what will be the output voltage? Same as V supply. Okay, just suppose from over here, if R1 is 0, then this terminal is connected with this supply. Okay, and we are measuring voltage from this terminal. Reference voltage is from the ground, we are measuring always. So, okay, let me clear it. This one is positive, this one is negative below side. Okay, so don't get confused about it. So this one is reference voltage. We are measuring from over here. This will be symbol like this, V output. Okay, so over here, what more thing I'm going to discuss? Yes. Okay, so if R2 is equal to 0, then what will be the output voltage? If R2, this one resistance is 0, then what will be the output voltage? This one is negative and this one is positive. 0. Okay, when R2 is equal to 0, then supply voltage, output voltage will be 0. Now what I'm going to do, I'm going to make it flexible variable resistor I'm going to make it. So variable resistor means this one will be the slider, this one will slide on across it, and R1 and R2 are variable. So this variable resistor is in potentiometer. So whenever we are scrolling this slider, R1 and R2 value is changing. When the slider is at the top, then R1 will be 0 and we will get output voltage as a supply voltage. And when the slider is at lower position, then we will get 0 voltage at the output. Hope you get understood about this voltage divider rule. If anyone having any kind of query, kindly ask. Okay, that's great. So now I'm going to relate this voltage divider rule in potentiometer, and after that what I'm going to do over here, I will use one sensor, and then I will see that what will be the effect of output voltage. Just suppose if I'm using any sensor, any resistive type sensor over here in replacement of this resistance R1, then whenever R1 will change, my output voltage will get changed. Okay, I'm going to repeat it again with the help of circuit. I'm going to repeat it over here so that you will get understood. So these are R1 and R2 resistance. This one is output voltage. When R2 is 0, means this wire is similar to connected over here like this. So this one is ground, and we are measuring from the ground. Both potentiometer port we are connecting over here with the ground, and we will get output 0. So similar way, if R2 is 0, then this terminal is connected directly with this sort. So you will get output across this resistance. So output will be equal to supply voltage. Let's see it practically so that you will get more familiarity about it, that how it is working. So let's see how it is working. So this one is very important, and if you get understood, then maximum sensor you can interface, that is resistive type. So I'm going to create a new circuit. So whenever you are going to create new, so don't delete your previous circuit, always create new circuit. Resistance output get attached by ground. Let's see how we can make it. Okay, create new circuit, and then let's see what happened over here. So now first of all we are going to understand about voltage divider rule and working about voltage and current. If you are having any kind of query related to voltage and current and voltage divider, then that doubt will be clear over here. So I'm going to use, not going to use breadboard right now, otherwise you will get confused. So I'm going to use one resistor over here, one resistor over here, then going to use one battery. So any battery you can take. So I'm going to use simple coin battery so that you will not get confused about battery. Yes, this battery I'm going to use over here so that you can relate this battery with the circuit, that this one is positive side I'm going to connect over here, and negative side I'm going to connect over here like this. Okay, so this one I'm going to connect with this resistor. Okay, so I made a circuit, and that is voltage divider circuit. From over here I can get output. So output, with the help of multimeter I can measure output. So for that, negative of this should be connected with this side. Okay, so negative is connected over here, and positive I'm going to connect with this output from middle of two resistors. So this one is those resistance out of two is connected with the ground. This one is R2. So it's easy to understand that which one is R1 and which one is R2. You should not get confused. So this one is R2. So over here, both resistance value is equal and supply voltage is 3 volt. So what should be the output? Kindly respond and let's see what output will be there in the multimeter. We will check it. 1.5. Very good. Very good. Half mean 1.5. Let's see how much output is coming. So output is 1.49, that is equivalent to 5 volt, 1.5. So we are getting 1.5 volt at the output. So now very important point I'm going to discuss over here, that is very practical point. You will not find it in a book. So just I'm giving you one problem that my resistance value is 1 ohm. Both resistance are 1 ohm. What will be the output voltage? So everyone is saying 1.5, correct. Okay, we will get 1.5 volt. Okay. So my both resistance value will be 1, but maximum is saying that you will get 1.5 volt. But I'm saying that we will not get 1.5 volt. We will not get 1.5 volt at the output. So anyone can say why? Anyone can say that why will we will not get 1.5 volt at the output? So kindly respond that why it is so? Why you will not get output that is that is not equal to 1.5 volt? Yes, very good. Someone is answering in a very good manner. Might be they have attended previous session. So thank you so much for your response. Okay, so what will be the logic behind that? Just see, first of all, I'm just making it 1 ohm. Then I will let you know that why it is not, both resistance value is 1, but why it is not getting half of voltage at the output. Half mean why we will not getting over here 1.5 volt. We are getting 250 millivolt. How much we are getting? 250, and both resistance value is 1 and this one value is 1. Both are R1 and R2 is equal. So according to calculation, it should be 1.5 volt, but practically it is not coming. And again, if I'm going to make a value of 100 mega ohm over here, and again 100 mega ohm at the R1 and R2 both are 100 mega ohm. What will be the output voltage? What will be the output voltage if both R1 and R2 is equal to 100 mega ohm? Kindly respond. 1.5 volt. Good. 1.5 volt. Very less response is coming now. Someone is saying 3.5 volt. 3 volt. Okay, let's see how much it is coming. So this one is 100 mega ohm. This one is also 100 mega ohm. So how much it is coming? R1 and R2 are equal. The value of that is 100 mega ohm, but we are getting 29.4 millivolt. But it should be, according to the calculation, it should be 1.5 volt. Why it is not so? So that is very practical approach. We have to understand that whenever we are going to design any sensor circuit, then we have to understand some practical concept. That is very important. So why it is happening? I'm just giving you a very simple concept that whenever the resistance value is very less across R1 and R2, mean when resistance value is negligible, then the maximum current flow this circuit and battery gets short circuit. Why get short circuit mean? When I'm just giving you a simple practical example, whenever we are using any heavy motor at our home, like AC or some heavy appliance, then voltage get reduced, voltage get dropped. Why it is so? Because the device that we are using is consuming more current flowing that device. So the voltage get dropped for some time. So similar with that, same thing is happening over here, that resistance value is whenever resistance value is very less, then maximum current flow through the circuit and battery voltage get dropped. So you can check it also, that I'm going to check it out over here. The battery voltage also, I'm going to connect negative with it. so that you can visualize each and everything practically, and that is possible due to this Tinkercad software. Otherwise these things we cannot visualize without having hardware and circuit, and maximum time we don't do that kind of practice in the hardware, so that you can do it your home using Tinkercad. So now I'm going to check it out. I'm going to change it again to 1 ohm, 1 ohm, so that you can visualize that what will happen. 1 ohm. Ohm is resistance unit. So now I'm going to run simulation. So you can see supply voltage is 3 volt, but over here you can see voltage dropped across the battery voltage. So you can see over here. So why it is happening? Due to maximum current flowing through the circuit. So that is the main reason of that you have to consider. So whenever this must be your question, that how much optimum resistance value we should use for any kind of sensor or any kind of voltage divider circuit. So the optimum value of resistance is 1 kilo ohm to 10 kilo ohm for any kind of voltage divider circuit, so that we can get optimum voltage at the output. So if I'm going to make it 10 kilo ohm or 1 kilo ohm, then we will get output like, if I'm going to make it 1000 ohm, that is 1 kilo ohm, I'm going to make it 1000 ohm. Okay. So now we are getting supply voltage 99, very small drop is over here. This one is small battery, then that's why there is little bit drop. So we are getting 1.49 approximate. If we are going to make it 10, this one is also 10 kilo ohm. So you will get exact 1.5 volt. So that also you can use 10 kilo ohm to 1 kilo ohm. That is optimum resistance value for a voltage divider role. Hope you got the answer right now. So now what we can do, if we are changing this R1 or any of two, then output voltage will get changed. So I'm just changing it to 1 kilo ohm, then you can see voltage is changing. We are again changing, then voltage is changing. So if you are going to make it variable or going to connect any sensor over here in replacement of this R1, then your output will change according to changing the value of sensor. So I'm going to prove it right now using one sensor. So I'm going to use any kind of resistive sensor. So this one is a resistive sensor. I'm going to delete it and going to replace the sensor over here in replacement of R1. So in R1 replacement, I'm going to connect one sensor that is resistive type. So let's see what we will get at the output when resistance value will be changed. So now I'm going to connect output here. Okay. So output is connected. Let's see. Okay. So we can also use with slider resistor, but I'm directly using this LDR. So let's see. Okay. So over here, we are getting 158 millivolt right now because this resistance value is different. And this value also you can check that how potentiometer, how this resistor is changing, that I have shown you in first session. So I'm not going to repeat right now. So I'm going to change it. So let's start simulation. And after starting simulation, one of the participants were asking that how we will get that light radiation in this sensor. For that you have to click over here. You will get this light in there. So let's see at the output voltage. I'm decreasing resistance value, and output voltage is changing. Output voltage is changing. Are you able to see it? So according that deflection of this sensor, this resistive type sensor, we have converted this deflection in the form of voltage. That voltage we can read in our microcontroller. because my Arduino understand the language of voltage. So whatever sensor we are using, we have to convert their signal in the format of voltage. Then only we will able to interface the sensor with Arduino. So now I'm going to use potentiometer. With potentiometer is also working as a variable resistor, variable voltage divider, that I shown you in the circuit also. So in potentiometer there are 3 pins. You can also see in the circuit. So over here in potentiometer, this one is a variable resistor. So this one is ground, this one is connected with the supply, and this one is output. So we are rotating this port slider from over here to here. R1 and R2 are changing like this. So this one is working like this. So hope you get understood. This one is a resistive, variable resistive element. So now we are moving back to our circuit, that how we can make potentiometer circuit and we can interface it with Arduino. So we are going to interface it, but before that I'm going to connect potentiometer. So how it is working, you have seen in the previous session also that potentiometer is a simple voltage divider. So this one I'm going to connect over here, and this one I'm going to connect over here. These are terminal 1 and 2, 1 and 3, and 1 is connected with 5 volt and 3 is connected with ground. Then it will work in a reverse order. Reverse order means when it's in beginning state, it will give output 3 volt, and when it is at the end, it will give signal that will be 0. So let's see how it is working. Okay. So I'm going to start simulation. You can see we are getting at the initial state 3 volt. As I'm going to rotate it, we are getting 0. So if we will change that polarity, then we will get the output according to reverse order. So I'm going to change this output from over here. Whenever you want to change anything, stop simulation and connect this like this. Okay. So this one I'm going to connect with this. I reversed the polarity of first and third pin. Now you can see. It's not difficult, simple potentiometer I'm just connecting. So now you can see polarity get reversed. So potentiometer, whatever input and output we are using, this potentiometer we are using in our fan also. With the help of that, we are changing speed of fan in our home. That is same potentiometer, there is nothing else. So whenever we are increasing speed, means we are increasing voltage. We are decreasing speed, we are decreasing voltage. There are 3 connections. One is positive, and second is ground, third is ground, and middle one is output. Okay. So now what we have to do, we have to interface this potentiometer with Arduino that we have already interfaced in previous session. So that I'm not going to do. I'm now going to interface Ldr sensor so that we can make some interesting project using Ldr. What we can make using Ldr, with the help of Ldr sensor, we can make automatic street light, or you can use that Ldr in day night vision camera also. You will find that sensor. So there are plenty of application of Ldr sensor, light dependent sensor or photo resistor. So this sensor I'm going to use. For that I have to build, I cannot interface sensor directly with Arduino. For that what we have to do, for interfacing this Ldr sensor with Arduino, what we have to do? Kindly respond in that box. If we have to interface this Ldr sensor with the Arduino, what we have to do? Okay, I'm making it a little bit slow. Okay, if we have to interface this Ldr sensor with Arduino, for that we have to make a voltage divider circuit over here. So how we can make it? Let's make first of all voltage divider circuit. So how we are going to make a voltage divider circuit? One same circuit we are going to create over here that we have created earlier. This one is R2, this one is R1. So this one I'm going to connect with positive 5 volt. This one 5 volt supply from Arduino I'm giving. This one is ground. I'm going to connect it with ground. Okay. This one voltage divider circuit is created over here. Very simple. You can create it upper side or lower side. It's up to you. So I have replaced R1 with LDR, nothing else. So let's see what output voltage is changing. You can check it with multimeter. So output voltage, I'm just checking it. This one is negative. Negative should be connected with ground. This one is ground terminal. So this one is output. Output should be connected over here. Okay, let's see. We are giving supply voltage, that is 5 volt. So with the help of Arduino, I'm just giving power right now, nothing else. Yes, we can use with 10K also, and we can use 1K also. So I'm just using right now 1K to 10K, any register you can use as per your availability. So this one is R1 and this one is R2, this one is LDR. So I replace that sensor, that resistance with Ldr sensor. So let's see. I'm just changing light intensity. You can see voltage is changing or not. Voltage is changing whenever I'm changing light intensity on LDR. So that we want that output should be changed. The resistance or LDR output should be changed by changing light intensity in the format of voltage. We want output in terms of voltage so that we can read in the Arduino. So what we did, we have used one resistor or one voltage divider circuit. So now it's changing, output voltage is changing according to light intensity. So what is happening in this LDR? So LDR resistance is changing, but we are getting at the output over here, that is voltage output. So that output we have to connect with Arduino. So which pin? Analog pin, because it's giving analog output. Because we are getting output over here, that is analog output voltage. So I'm going to connect this output with A0 pin, that is Arduino. I mean, I'm going to read this value in Arduino, this output value. Also checking in multimeter also here that what output voltage I'm getting here over here. Okay, now I'm going to run it. Let's see output. The voltage we are getting 27.7 millivolt. As I'm changing, output is changing. So that voltage we have to read in the Arduino. So for that we have to write program. So when brightness will increase, you can see what is happening over here. When brightness increasing, output is increasing. When brightness decreasing, output is decreasing. So we have to write a code for Arduino right now. Let's see how to read analog value in the Arduino. So the analog reading principle and analog reading code will be same as we have created earlier. So there will be no change in the code. So how to write that code in a very simple way? Let's see. So first of all, what we are doing, we are reading value, that is analog value. Got it? What we are doing now, voice is clear or not? Voice is clear or not? Kindly respond. So there is some connectivity issue, no need to worry. Now I think voice is coming clear. Now voice is okay. Okay. So there is some internet connectivity issue, no need to worry about it. So it will get automatically stable. Okay. So first of all, what we have to do, we are reading value, that is analog value. So we are taking input in the Arduino. For that, what we have to do, we have to go to input block. Which block? Input block. So we have to go to input block. Over here, their first option is read digital pin. And second option is read analog pin. Which block we have to take? Kindly respond. Which block we have to take? That we have to take analog block. Very good. So this block we have to take analog block. So we use this block for reading value from A0 pin. So A0 pin we are using. So now what we have to do, whenever we are going to read any analog signal in the Arduino, that value we have to print somewhere. So where we will print that value should be printed on the serial monitor or LCD we can use for that. So LCD we will use later on. So first of all, what we are going to do, we are going to print this value at serial monitor. So serial monitor will be the output. For that we have to go to output, and over there you will find one block at the end, that is print to serial monitor. Take this. So over here, what value we want to print? If we will not put any value inside it, then we will print only hello world. Then we will print only hello world. So, but we want to print this value over here in the serial monitor. So let's see without it, what will be the printed on the serial monitor. So you can see serial monitor over here, and this one is serial monitor. So I'm going to start simulation. So at serial monitor, you are finding hello world only. So now what I'm going to do, so I want this analog value should be printed at the serial monitor. So I have put it that block in this serial monitor hello world in replacement of hello world. So now I started simulation and see we are getting value that is 6. So why it is getting 6, that we will discuss right now, that why it is getting 6, because we are reading value in the format of 10-bit ADC that is inbuilt in Arduino. So let's see, whenever going to change value over here, what will be the change over here. So I'm going to change this value. You can see voltage is increasing and output is also increasing. So this output is coming in the format of 0 to 1, 0 to 3. So how it is coming, that I'm just going to discuss you little bit in detail, that how we can convert it in a 10-bit and how we can convert it back in the format of 0 to 5 volt at serial monitor. For that, what we have to do, I'm going to use one formula. That formula I'm just going to discuss first of all, so that you should get familiar that how this formula came. So over here, first of all, I'm going to clear over here. Okay. So let's see how this formula is coming, the 10-bit, how we are reading that value. I will repeat again that coding part, so no need to worry. So just suppose we are reading in the format of 10-bit. 10-bit means 2 raised to power 10. So we are reading in the format of 2 raised to power 10. That is equal to 1024. Let me change this drawing part. 1024. So we are reading in the format of 1024. So kindly don't look towards writing over here. So now what we have to do, it reading bit means 1024. So whenever we are going to read in 0 to 5 volt, whenever we are going to supply 0 volt to 5 volt in the Arduino, it will read in the format of 0 to 1023. 1023, because 0 is also counted in bit format. 0 is also counted 1023. So 0 is also counted 0 to 1023. Total value is 1024. Okay. So now just suppose we are giving supply 0 to 5 volt in the Arduino. It's reading in the format of magnifying scale, that is 0 to 1023. Okay. Now see, you have an option to type C. So the typing option is for text only. In text, I think we are not able to write value. Let's see. Yes, we are able to write. So 2 raised to power 10 is converted in the format of 0 to 0 to 1023. Okay. So now what we have to do, we have to convert 0 to 5 volt again. So what we have to do, just suppose I'm going to show over here 5 volt, it read in the format of 1023. So I'm going to make it reverse, that 1023 value we are reading 5 volt in the Arduino, because we are going to convert this analog, this 10-bit value in again in 5 volt. For that, what we have to do, 1023, whenever we read value, it will convert in 5 volt. It will read in 5 volt. Now I'm going to convert it in 1 is equal to 5 divided by 1023. If x value we are reading, then what will be the formula? 5 divided by 1023 multiply x. This will be the formula. With the help of that, we can convert that analog value that we are reading, the analog value that we are reading from. Audio is coming or not right now? Audio is coming or not? Kindly respond. Yes. So this one is a formula for converting again that 10-bit ADC to 5 volt. So if just suppose x value is 1023, mean we are reading value 1023, what will be the output voltage? Kindly respond. If x is equal to 1023, what will be the output voltage? What output we will receive? 5 volt. Great. So that formula we can use in the coding, and we can convert it from 1023 to again in 5 volt. So let's see how it is working. So let's go in coding again. So over here we have to convert it again in the format of 5 volt. So how it can be done? Let's see. For that, there is one math operator, that is map. There is one function in the Arduino, that map. With the help of map, we can directly convert. That formula is embedded in the background in the program, in the function that we do here. That also we can do with that formula. I will let you know later on with the help of that formula also. So I'm going to use this map. In this map, how we have to use map function? Let's see. So which value we are going to map, that we have to put over here. What range we want at the output. So I'm going to put this value over here, or you can duplicate also it. I'm going to put over here. So I'm going to map this value, and what would be the output? Output should be 0 to how much? 5. So we want to map this value from 0 to 5. So what we have to do, read this value. We are reading from analog in format of 10 bit, then we are converting it in a 5 volt. So after converting it, this value is in this block. So if we want to print it, then remove this, and now you can map. See over here how I'm doing it. I'm going to put this block in this over here. You can do it like this. Okay, I'm putting it over here. Got it? I'm showing it again. So this block, I'm going to put serial hello world over here. Now it is converted in the format of 0 to 5. Let's see how it is working. So let's start simulation and see at the serial monitor. we are getting, just see, we are getting 0 volt. So it's coming in millivolt. So it will not read in float, it will read only by integer. So if we have to make it to read in float, then we have to take some variable also. So just see how it is working. I'm just increasing it, 1 volt, 2 volt, you are getting 2 volt over here. So 0 to 5, it will change. 3 volt, yes, 3 volt, 2 volt, up to 3, it's changing. So we have converted it again in the format of 0 to 5. Yes, it will automatically take 0 to 5 in mapping. Yes, we have to change it. In map function, we have to change it. If we want to make it reverse, that also we can do. For that, we have to do 5 to 0. So if we are doing, if we are doing it from 5 to 0, that also will work over here. Let's see how it is working. So over here, now it will work in a reverse order. Mean initially we will get 5 volt, and as we will change, it will reduce automatically. Voltage is increasing, output is over here decreasing. Yes, I'm showing it. Someone is asking about in float number. For float number, we have to write in the code format so that we can show you in a very simple way. So I'm just going to show you that how will be the embedded code here. This one will be the embedded key C code. This one is a function and map syntax we have used. So that is simple program we have written. And over here, this one is serial begin for serial print applications. This one we have defined A0 as an input, and this one serial print command we have used for serial printing. So how we can take it in a float, that I'm just going to show over here. So I'm just going to show you simple code over here. So how coding you can do. If we want to edit this code, for that what you have to do, go to code, over here block plus text. So you have to go to text only if you want to do any kind of modification in C code. So I'm going to explain each and everything over here. So this one is a pin mode we have to use for input from A0 pin. This one is function for serial beginning. If we have to print a serial monitor, then we have to use the serial begin function, that is library that is included in Arduino software. So again, 9600 is a baud rate, that is broadcasting rate. With the help of data is being transmitted, that sampling rate, this one is a sampling rate, that how much speed of the data we want. We can increase it or decrease it. There are few standard baud rate in the Arduino. Okay. So now over here, I'm just going to rewrite again in a very simple manner. First of all, I'm going to take one integer, any integer, like I'm just going to take a Ldr integer is equal to, so if we want to read value from the analog pin, then we have to write block analog read this one, then we have to put pin number, which pin we want to use. This one is a simple code for reading the block we have used in the graphical way, that analog read block. So the value whatever we are reading from A0 pin, that can full screen properly. Okay, let me zoom it. So are you able to see right now? Are you able to see in a good way? Okay, good. So over here, what I'm going to do right now, LDR, I taken one variable, that is integer. The integer I have taken, a data type is integer, a variable name is LDR. So now what I'm going to do, this value we have to print at the serial monitor. So I'm step by step, I'm going to explain over here. Program is over. My program is complete. 2-line code is there for reading analog value. There is only 2-line code. That first line we have defined over here, this analog input. This one is for serial print, and then this line. Now if you want to print this value at serial, this one is double slash for comment. This line will not executed in the program. So if we want to print serially, so we have to write it serial dot print, and then we have to put that LDR value, that variable value in which our analog value is being stored. Yes, my code is complete. Now I am able to see my analog value at this serial monitor in the format of 10-bit. But are you able to identify it, that how much value we are reading? Are you able to identify it? Yes, we are. Yes, it is not float. We will take in float also, no need to worry. So over here, we are not able to identify. For that, what we have to do, we have to print it in a new line. For that, I'm writing over here LN. It is not IN, it is LN. LN means new line. Whatever value we will print in loop, the next value will be printed in a new line. Now you can see, you can visualize. We are just reading right now the value in the format of 10-bit. You can see value is changing from 0 to 1023. Now we have to convert it in a 5 volt. So first of all, I will let you know how you can use it without mapping function using that formula that we have used earlier. So here variable is LDR. So we have to put formula over here. So what formula we have to use? We have to take one more float variable, float voltage with the name of voltage. I'm just taking any name you can take, any name you can take. Float voltage is equal to 5.0 divided by that formula I'm using over here, 1023, this one, and multiply with X. What is X? X is this LDR value, the value that stored, analog value that stored in the 10-bit. So this I'm going to copy over here, I'm going to paste. Why I'm taking it 0, 1.23.0? Because we are reading value in the format of float. For that we have to take this number also in the float. Okay, now see, we have converted that value of LDR from 10-bit to 5 volt, 0 to 5 volt in a variable voltage. So now we have to print it again in this voltage value in the serial monitor. So over here, what we have to print? So what we have to print over here? We have to print over here that voltage. Okay, so I did it, but very important point, if you are using it in a small, it should be over here in a small. It's a case sensitive. I'm repeating it again. If you are making it capital and making it small over here, and you are using over here in a capital, then whenever you will start simulation, you will find error in your circuit. You can see error. So what you have to do, you have to take it small, in small, same. Okay. So now we are going to print it voltage. So if you want to print this voltage, so comment upper LDR value so that you can see this value. So now I'm going to start simulation. I just put it comment over here. Why I am put it comment over here? Reason behind that I just want to print only one value. So it's saying that put some semicolon over here. Okay. Yes, it's case sensitive. So it's working now. You get the serial monitor. We are getting value in the format of float. You can see over here. Now I'm going to change over here. Value changing and value is coming in the format of point. You can see exact value is coming in the points. 3.3 volt. Whatever voltage we are reading, same output we are getting. Got it? Everyone got it? This one is a formula that we have used over here. Now, if we want to use map function, so how we can use with a map? For that, we no need to use this formula. So what we have to do for using map, we are going to map it directly with formula. Just see it. I'm going to use that map function. In map, we have to write it like this: map, what we want to map, this LDR value we want to map. So LDR we have to write LDR. So first of all, we have to define LDR range. So that LDR from where to where it can read. It can read 0 to 1023, and where we want to map it, 0 to 5 volt. This one is a simple syntax of map function, and then we have to store it. If we are taking it in a float, then we have to make it 0, we have to make it 5.0. Okay, that's all. This one map function we have to use. So over here we have to write it, but in a graphical we have to use it simple map function, map block. Over there we have to just put from where to where we have to change value. Now I'm going to start it, run it. Let's see it is working or not. If there will be some error, it will show. Okay, you can see output is coming. So I'm going to change it. So it's showing some error over here. Yes, it's coming, but it's not showing in the float. For that, we have to check it that the whole value is in float or not. 0.0. So value is mapping. So I'm checking it to, okay, this one is not in float. I'm just converting it, this only float, output float. Let's see. So now I'm going to change it. So output, my output is changing or not? It's changing, but it's not coming in the float. So we have to convert it in float also, upper variable also. Let's take float. Then see 0.02 1023.0. So similar way you can do it in a very basic format. So map function you can use it over here. It also showing in not showing in the float, so that we will troubleshoot later on. But you can use that map function and you can print value as a output from 0 to 5, and you can map it in reverse order also from 5 to 0. You can do 5 to 0. So in this order you will get output in a reverse order. So that is all about mapping function. I'm again going in graphical coding so that you should get familiar. So whenever you are going to change over here and you will go in graphical code, your code will get deleted automatically. So for that, whatever code you have created, you can save it. Otherwise your code will be get vanished. So for that, I'm going again in blocks, continue. So you can see over here, my code is get deleted. So I'm going to reduce some screen size. Okay, so over here, again, I'm going to show that how you can use map function in a very simple way. So for that, I'm going in input, take read digital, and also you can see in graphical that what is coming in embedded C code. So analog read, then we have to go to map. In map function, what we have to do in map, 1 second. Okay, so go to map, where you will find map in math. This one is map function. So what you have to do, you have to map this value, this analog value, where to where you have to map 0 to 5. So you can make it 0 to 5. Okay, so your program is ready, but you want to print it. You can see it at the end also what is coming. Map function is coming over here. In map, what is coming, that also you can see over here, that in map what we want to map, this analog value we want to map, and from where to where we are reading this value 0 to 1023, and now we are mapping it from 0 to 5 volt. You can see in a very simple manner. So now what we have to do, if we want to print it, you can see there is no serial monitor right now, serial begin right now. Whenever we are going to take output, that block is serial print, then automatically we will get serial begin over here. You can see. So this value we want to print, put it over here. Yes, my code is ready. Serial print is going to do with this value, and we can start simulation. So if we want to use with some variable over here, that also we can do. So I'm just going to show you after this. So I'm not going to show serial monitor right now. So if we want to use with some variable, that also we can do. For that, go to variable, create variable. So variable I'm going to take like LDR. So LDR variable you can take. So LDR set value 0. This one is LDR value, or we set store value in this LDR. What value we want to read? This value. So after that, what want to map? This LDR value we want to map. Okay, so you can see over here what we have taken a global variable, that is LDR value is 0, and then what we are doing over here, LDR is equal to analog read, whatever we have written in the code, that same thing is coming. Serial.print ln for new line, map function we are using LDR value 0 to 1023, 0 to 5 delay. Same thing is coming with the help of that variable. So hope you like it, hope you enjoyed it. Each and everything is linked with the IoT. If someone is saying that this is not related to CSC, everything is linked. If anyone thinking that I'm a mechanical engineer and it's not related to me, whenever you're going to participate in any industry or going to join any industry, everywhere you will find IoT, because now we are living in an era of fourth industrial revolution. So if you are not familiar about these things and you don't want to get familiar about these things, then it will be a very big problem for you, and that can be big trouble for your career also. So if you want to secure your career, then you have to learn each and everything, and you have to become multidisciplinary, and you have to apply multidisciplinary approach. So no need to worry about WhatsApp group. If anyone facing difficulty, kindly WhatsApp me on my personal number. So over there, I will add you in vacant WhatsApp group. So no need to worry about that. So any query, any other topic right now is question answer session. So YouTube link I have amongst your students, so that student can get benefit out of it. They can learn IoT basic fundamental. They can understand basic principle of sensors, microcontrollers, because whenever we are going to interface any advanced sensor for IoT application, if we are not understanding basic fundamental, then we will not able to do that application. So it's very interesting and very important, and you can simulate at your home also. It's not like that you need hardware or anything else that you can do. So any doubt, you can ask it. I'm going to share my number again. So if you are having any difficulty, you can ask anytime. So you can WhatsApp me